this one? I'm not sure.
90 is weird.
Is it so? This would be the one line,
Yeah.
or you don't? And like, is this the one? This would be the one.
Why does it keep going?
Oh.
Yeah, like it's saying that.
Oh, so this because right here, this is the. Do you see that?
Yeah.
Oh, that's that.
But it doesn't fall.
What is it? It's gonna fall back down.
It just goes.
It's gonna be like here.
No, whatever it is, right?
That. Right, Misty, or that?
3.7.
Can I ask why you think it's gonna go back down?
Well, because if this is the 90
Oh,
degrees, that means
oh,
it's the
45.
center, and like,
Okay.
and the quadrant's like a circle, so basically it's probably
This is
gonna go like this.
8.8.
Like that, in a circle.
Awesome. Yeah, I like that explanation. So you think because it's a circle, it's gonna curve back down?
I thought this was a circle until I seen this, because if this is 1, right here, 90 degrees
Yeah.
1, that means it's the center, meaning this is the center of the left, right, all corners.
Okay. Yeah. Let's keep going through the slides and see how that plays out.
Does that make sense? You get it? 5.
No, wait, how do you...
Yeah. So we're predicting right now. We're going through this rotation.
The way down compared to the heights on the way up. What do you predict will happen as your degrees continue to increase?
As we go through each degree,
What I noticed is that like
our
it's a curve.
height increases.
Like
So
you start
it starts at the
you
water
start low
level,
and then you work your way up. And once you get to 1, you work your way back down to 0.
And then the next degree is 45 degrees or 30 degrees. He's at this height, and it keeps increasing his height. So for this slide, I want you to predict if he's at this highest height and he's going around this circle, what is his height going to be if we were to graph it in this section? Do we have any ideas?
When it goes down,
Yeah.
at the up,
Well, why? What makes you think it would go down?
actually, because power increases. Okay, up.
Yeah, I want you to think about his rotation around this circle. Because right now he's at the top of his circle, and it's graphed up until that point. If he keeps going around the circle, where's his height going to be?
No, wait.
So he starts. He starts at 0. That's here.
No, you did it right.
And he goes 15 degrees just this way. And he's right here. Then it goes up and up and up and up, and we're at the top of our curve. This is our highest point.
Well, because you already know how like the full circle is 360, right?
Yeah.
And you know how that's like. I think we're always going to be using this because, like, for instance, I think on problem 4, the whole thing is like. Have you done the worksheet yet?
Most of it, yeah.
Oh, because if it says like if it tells you the not radius, the radius, if it's like 240, but we want to know just this, then we subtract 180,
Yeah.
like that to get that as well. So I think that's why it's helping us understand. What do you notice about the height on the way down compared to the height on the way up? The height
Showing
on the
that
way
he's going to go back around that circle.
It's gonna go back down.
The side.
So yeah.
when it goes down, it's subtract over.
All right, we're going to check in one more time because it looks like we're at that slide 9. So I'm going to pause in just a second. Okay.
What do you predict is gonna happen as your degrees?
Slide 9. It's going to show you your curve so far. And it's asking again to predict and draw what you think the degrees are going to be as you continue. So I want you to draw in these two regions
We'll go back.
what you think Freddy the Frog's height is going to be. And then just for slide 8, there has been some confusion. Once you fill out this table, it's asking what do you predict will happen to your degrees. It's asking after 180 degrees. So if you keep going past 180 degrees, what do you think his height is going to look like? So that's just some clarification. I'm going to open up the rest of the slides and I'm going to pass out a half sheet of paper. The slides after Slide 9 will help you answer the questions on here, and some of them you can just answer on your own. They're pretty open-ended questions, and at the end of class, we're going to talk about our answers for some of these questions. So maybe be prepared to share. I'll create some guidelines for that once we get there. But for now, I'm going to open the rest of the slides and pass out these worksheets, and you can continue working. Yeah, Martin.
Is that paper with your partner too, or is it individually?
You're going to get this individually. So this is how you're going to get points. Since you're doing Desmos together, I'm going to grade you on your individual piece of paper. Great question.
Te toca.
Past one individuals?
Yeah.
Okay, so
The height?
Yeah, whatever you think his height is going to be, that's fine. Do you think his height's going to go down? Or not? Why do we think his height's going down?
Where did it go? But it wouldn't go negative that far now. Oh wait. No, because the
it's just gonna be.
Yes, awesome, great. So he's going to go around the circle.
Cool. See how down here the negative? So it's gonna go into here.
Oh, yeah. Okay.
Oh,
So
105.
think about just at the scenario.
Oh, because
Wonder what would happen if the real
Is it
rate. You
repeating?
agree? If the real
Yeah, it's
rate
repeating,
is
so
two,
it's
it
going
would
to-
just go higher.
Yeah.
But it'd be shorter, right?
Yeah.
Yeah, because it'd be tighter.
what did you think will happen as the degrees continue to increase? The high will start to go up again. So the high will repeat. Once it reaches So yeah,
We
each
learned
time
the
it
same.
reaches the x-axis, it will repeat the same height. Do you want to write? Oh, that's the whole 360.
Yeah.
Okay.
Why? I don't really get why it's.
Oh, wait.
Why it's going like that. I thought the circle.
Oh, for this one.
Yeah, because he's rotating in that one spot. So this is showing his height at every degrees, but each degrees we move forward on our x-axis. So at that, like, can I show you? So at this point, our 0 degrees, he's at a 0 height, so our point's right there. If we move this way, we've rotated 15 degrees and our height is here. So you can see as he rotates, it's adding degrees and our height is increasing. So that's why they're spread out. Does that help answer how this comes over here?
Because he's moving out, right? Or his degrees increasing.
Yeah, our degrees is increasing. Like this is our degrees and we increase and his height is changing at each degrees.
And like I can say, like it goes down and back up.
Try to describe the shape.
But with a quadrant,
Yeah, exactly, because the quadrants he's moving through, like once he gets down to the bottom, he starts coming back up and you can see it shows that height.
So it's basically the quadrant just stretched open.
Exactly, yeah. So we're taking our unit circle and we're stretching it out.
you start answering. Slide to the
What did we say for some
This is what type of quadrant? I can't.
Oh, you have to draw it. Oh, we have to describe it too.
This one we said Angry Birds. I like that too. That's fine.
So after the 180, it just goes.
It's like a,
Oh, I did the whole
like a
graph.
stretched out S.
Drag the left.
Why did I like that? Okay,
With the graph on, I can see that. Do you get this?
Checked out.
The
So
graph
you
on,
just
you
really
can see the right triangle
what is this curve
with
look like?
the rotation.
Answer that in the second one.
The red side of the triangle is opposed to the triangle.
I get it. Are you asking about like the triangle? So like
The shape looks like wait.
it's like flipping. So it starts right here and then it goes down and then that's where they're like this
What?
and then it keeps going
The
down.
frog?
What is
Oh, yeah.
is real word real
At this point, I really want you to start finishing out those little half sheets so that we can talk about it in about 3 or 4 minutes.
Where would you see this realistic?
right? Well, I should know. Maybe
Is Ferris a Ferris wheel?
oh, the fountain thing.
What is that even called?
Oh, they're like
You just go.
What is that called?
The water wheel. Let's think of a different example.
that's not
What
the
is-
beach.
Why does it look like the beach? Like in what way?
The waves go up
I
and
love it.
I told you.
That's a great
That
example.
doesn't make sense. How would that make sense?
This looks like waves. I'm just asking what this looks like too.
So you're
I-
okay. Hold on. But are you looking for an example where we might find where we graphed, or where we might find this come into play?
What you graph.
That's why I said the beach. And you said no. So that's why I just put the beach.
Science. And what example? Measuring like wavelengths like in like water, but also like sound. So maybe we could write that for our when you're hiking a mountain, you're trying to get to the peak. Oh, it's called feet. What is it? I remember that. 6th grade science. Are you like shocked? Because I would think of like where things eat out of it and it's built like that. Discover the graphic sign. Oh, so it's just asking what type of function. And it's saying, what's the sign for?
Wouldn't it go bigger? No. Yeah, it would have. We could put that no. That's like
Whatever it looks like to you, actually okay. The crest. That's what it's called. The crest is the top and bottom. I don't know if yeah, that's like the middles. That's like where the water
It
is.
will go backwards so you put
I'm so excited about this.
You see the little wave? Oh yeah. The top is called the crest, and the bottom. This is that the bottom?
Yeah, sure. Like, what would that look like? Okay, if a radius is inconsistent around the shape.
Think about ways that this scenario could change and finish the statement. I wonder what would happen if, for example, I wonder what would happen if the wheel's radius was 2 meters.
That's a great
I wonder what would happen if
the radius was like a fraction. Is that possible? Because you remember this,
like if it was less than 1.
be a less than one.
in a second.
'Cause I feel like it would like expand. Because, I mean, the wavelengths would be a lot longer.
Alright, I'm gonna give you guys a quick task
Or, I mean, it
that'll
would be
help
bigger, no?
lead us into our discussion. So, what I'm gonna have you do is in your table groups, so the larger table groups, sorry you guys are just a pair right now. In your table groups, sorry, I'll eyes up here just really quick, just so I can get, okay great. In our table groups, we're going to talk about what we wrote for number 3, which is where's a real world example where you might see that curve. You're gonna pick one that's your favorite, and I'm gonna say 60 seconds, I'm gonna call on each table and you gotta share your real world example. Maybe think of 2 in case someone takes your idea. So in 60 seconds, I'm gonna check in and go to each table, figure out what your real world example is that you wanna share with the class. Sound good? Okay, talk about your real world examples and pick one for your group.
We said the beach. We said the beach. The beach.
Or what about hiking?
No,
That's
I'm
the
saying
mountain. No?
Doing like the,
But would you see this in a Ferris wheel?
no,
Why not? Yes, you would.
no, because the Ferris wheel is
Yes, you
not.
would. Because if a person is on a point, it's gonna go like this.
Yeah, but we're not.
But it's gonna-
the shape we're doing is S. The Ferris wheel's not rolling down the.
No, it would work.
That would be if we're doing about the specific, but this is the S.
No, but this is the way. Because if you think about it, it's
I mean,
still.
if the, we'll say a broken Ferris wheel if it was rolling.
All right, let's wrap up those conversations. Everybody have an idea of what they're gonna share? Right. I'm gonna start at table 1. What did you guys come up with for a real world example?
Radio waves.
Radio waves. So we see these in radio waves. That's how we hear sound. Let's go to table 6. What did you guys think of?
Oh, we said sound waves.
Sound waves. Awesome. Let's do this table. What did you guys come up with? Ocean waves. Yeah, ocean waves. Lots of waves going on. I'm gonna call on this table. Table 4. What do we got? What's our idea?
Rolling Ferris wheel.
The Ferris
A
wheel?
rolling Ferris.
Rolling Ferris wheel. I like that idea. A rolling Ferris wheel. That's very similar to our water wheel, but it totally works. Let's go table 2. What's our idea for a real world example?
Like a heart monitor, I guess?
Oh yeah, a heart monitor, so it measures our heartbeat. It'll go up and down. Awesome. And then table 6, what do we think of?
Like waves.
Light waves. I love it. Lots of science intersecting. Were there any ideas that you guys came up with that haven't been shared? Yeah, you have a question? Light waves? Oh. Yeah, because they're kind of going up and down the Christmas lights. I see it. That totally works. Do we have other ideas that haven't been shared yet? All right, I loved these ideas. That was awesome. So at this point, I want you to stack up those half sheets. I'm going to collect them. That's how you're going to get points.